Hello everyone. So today I'm gonna be discussing the data science assignments first 5 questions. Let's start with the first question, which says explain the difference between supervised and unsupervised learning. Provide examples of algorithm of each type of learning and discuss scenarios where each would be appropriately used. So let's first know what supervised learning and unsupervised learning. So there are basically two parameters which we use to differentiate them, which is the data type of the supervised learning and the goal which we are trying to accomplish. So in supervised learning is a task where model learns from labeled training examples. That which means that data type which we have in supervised learning is labeled data. What is labeled data? It has input features plus labels for the output. Whereas unsupervised learning is a task where model attempts to infer pattern or structure from unlabeled data, which means there's only input features, there is no output labels. That's why it's called unlabeled data, which is utilized by unsupervised learning. Now we need to know the goal. What's the goal? Why are we doing this? Because if we are doing some learning, we have a goal. So the goal of supervised learning is prediction. And how do we do prediction? If you have watched my previous video, you'll know we do it by regression or by classification. And what is the goal of unsupervised learning? It is to find a structure by clustering or by association. Structure discovery is the main purpose of unsupervised learning. So this is the major key difference between supervised and unsupervised learning. Now examples of algorithm where we use them and where we use them. That's we also need to know how and when to use it, right? So the supervised learning, we can use decision tree, we can use random forest, we can use logistic regressions. In unsupervised learning, we can use k-means clustering or we can use PCA, the principal component analysis. So in what kind of scenarios are we using these? So for supervised learning, we use it in spam detection or maybe image recognition, that for classification purposes, and regression for predicting something like predicting sales, predicting numeric values, predicting house prices. And for unsupervised learning, we use it for differentiating data and for data visualization. And heading on to the second question, here we have a table with terms origin, manufacturers, color, decade, type, class. So it's basically a table of cars. So the manufacturers of the car, what decade the car was, what type of car it is, and the origin of the car. And we have to draw a SI hypothesis. So first we need to know what is it. The hypothesis space. It's a machine learning concept in machine learning, in which we take all the set of possible hypotheses, models, functions, and everything that learning algorithm can consider, and then we use all those hypotheses, search them through the training data, and find the best one, and that best one is then used for training. So for this, let's first we have a null hypothesis here, H0 or HO, which is 55555, because everything is empty. Now in instance 1, we need to put the first row over here, which is Japan, Honda, Blue, 1980 economy. And instance 1 is positive. Please know that the class is positive. So H1 is equals to Japan, Honda, Blue, 1980 economy. In instance 2, what we are gonna do is we are gonna, since this one is negative, we don't need to copy it. We are gonna ignore every value which is H2 is equals to H1, means the value which are same as in H1, we are gonna ignore them, and the one which are not matching, we are gonna replace them with question marks because the value differs. We don't know what's gonna happen to it. So let's take instance 3, Japan, Toyota, Blue, 1990 economy. So economy and economy matches, we don't have to change it. Blue and blue matches, we don't have to change either. Japan and Japan matches, we don't have to change that either. So question mark and question mark for manufacturer and for decade, because Toyota is not equals to Honda and 1990 is not equals to 1980. Now instance 4 is again negative, so we are gonna ignore H4, H3, and we'll head to H5. So in instance 5, Japan is equals to Japan, so nothing is changing. But here we had Toyota and Honda, which was a question mark anyways, so yeah. Now again, we had blue, we had blue, we had blue, but now it's white. And white is not equals to blue, so we're gonna put another question mark here. And decade was a question mark anyways. The type was economy, so economy, 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 which is remaining same in all the positive classes, so we'll write economy. So this is our final instance which we are drawing through our S hypothesis, and which is Japan question mark question mark question mark and economy. Now on towards the third question. Explain the purpose of training, test and validation sets in machine learning. What is cross validation and how does it differ from a simple train validation test split? So we have three kind of tests. No, we have two kind of sets, and then we have a test set as well. So what is the purpose of each one and why do we use them? Training set, it is used to train the model. Model can learn its parameter from the data and what it needs to do. It's the basic step. The baseline model is learning everything in this stage. The validation test, it is used to tune the hyperparameters and prevent overfitting. Now what's overfitting? It happens when during the training stage everything was going perfect, but when new data was introduced, everything goes wrong. So to prevent that condition known as overfitting, we have a validation test. The test, which is the final set, which is used to provide a final unbiased evaluation of models generalization performance on unseen data, which means it is the final data set which we are trying and using it before finalizing our model. The second part of the question was, what is cross validation and how does it differ from a simple validation test split? So cross validation is a technique where data is split into k parts. K is any numeric values and model is trained k times, each time using a different fold as a validation set. Now what was a validation test? Which was trying to prevent overfitting on the training set. So cross validation does the same thing but k times. Now how is it different from a simple split? So simple split uses a single fixed validation set. There is no variance, there is nothing new, but in k sets there is k times data. It can differ. So hyperparameter tuning result depends on a specific split in a simple set. But in cross validation we have a more robust and reliable performance because every data point is used for validation exactly once, which leads to a better measure and also variability. Now in the fourth question we have a confusion matrix. We need to find classification accuracy, precision, recall, type 1 error, type 2 error, F1 score, sensitivity, specificity, and we need to also know the importance of precision recall as compared to accuracy, and I'll also give you an example. So classification accuracy is TP plus TN divided by N, 4 plus 2, N, which is the total value, 8 plus 4, 12, 18, 20, 6 divided by 20, 0.3. Precision, TP upon TP plus FP, so 4 plus 8. So TP is positive, TN negative, just so that you know. So 4 upon 12, 0.333, it goes on a bar. And recall, which is also known as sensitivity, is TP upon TP plus Fn, 4 upon 10. 4 plus 10, which is 0.4. Similarly, we calculated type 1 error here, 8 upon 10, 0.8. Type 2 error, false negative rate, 6 upon 10, 0.6. F1 score was 0.363. Sensitivity, which is same as recall, it's nothing different. And specificity, Tn upon Fp plus Tn, 2 upon 10, 0.2. But what's the main part of the question is we need to explain the importance of precision and recall compared to accuracy. So accuracy can sometimes be misleading because sometimes data sets are imbalanced, where one class might be big, another might be small, then there might be another bigger one. But those things can be addressed by precision and recall. Precision addresses the cost of false positive, that is type 1 error. Like you can see here, precision rather than accuracy uses this in the denominator. So it is addressing the cost of false positive, and high precision is important when alarm is high. If alarm of a false alarm is high, like spam or fraud is high, then we need to be precise. Recall addresses the cost of false negatives type 2 error. Type 2 error was 0.6 in this case. So it is also vital because cost of missing a true event is high, like missing a cancer diagnosis or fraudulent transaction. We can't miss it. It's very vital, right? We can't miss that. We need to have it. So that's why recall and precision can become slightly more important in accuracy. Now let's take an example. In a fraud detection model, if the fraud rate is 1%, a model that always predicts no fraud will have, but its recall will be 0%. If recall will be 0%, it will miss all the fraud cases. Even if it is 1%, it still amounts to something. So it will make it useless, right? Therefore, precision and recall need to be very important, and they are very relevant to evaluation of a model success. Now towards our final fifth question, discuss the importance of dimensionality reduction in machine learning. Compare and contrast features of extraction and feature selection as two approaches to dimensionality reduction and provide examples of techniques used for each. Okay, so dimensionality reduction is important. Why is it important? Because of course dimensionality will give you a curse. It combats that curse. It reduces features and it lessens the amount of data to achieve the significance, because data can be large, it can be huge, it can be humongous. So dimensionality reduction reduces the amount of data, which makes it very important. So as data is improved, everything will be faster and improvement will become better, and everything, performance will rise up, memory will be less used, therefore it improves performance. Data is less noisy, irrelevant data is removed, and of course overfitting is reduced. So since data is now structured data, there is no irrelevant data, so we can also enable visualization in this case, since data can be plotted. So the difference between feature extraction and feature selection. Extraction selection sound similar, but there is a slight difference here. So concept of feature extraction is to create new synthetic feature, and the selection feature, it selects a subset of most relevant feature. So what extraction is doing, it is creating a brand new feature, but selection, it is selecting a feature from a subset of already available ones. So new features here are combination of original features, and here new features are the original features themselves. There is nothing different. Techniques example, in feature extraction we have principal component analysis, PCA, or in feature selection you can say filter methods, wrapper methods, recursive elimination, etc. That's it for this video. In the next video we'll do the final 5 questions of our assignment. Thank you.